Here's a demonstration of a valve being tested. This is a 7A7. It looks like a mixer or oscillator valve. What I'm going to do is I'm going to run through the test procedure to test this valve. So the 7A7 requires the socket being plugged in at socket F, which is what it is. The two selectors here are 6, and the socket B is switch B should be turned to 2, which it is. Filament voltage 6.3, which is set, and then you've got left potentiometer set to 58, which I don't know if you can see that, the light is 58, and the right potentiometer is 22, and that should give you the good bad reading. Now if I press the meter down, you can see, I mean this lead out the way, that it's barely, where I lost the button, barely getting into the good. Well, it's not actually in the good at the moment. Just go to macro on this camera. This is a different camera I'm using today. So yeah, we're barely going into the good. The mutual conductance for this valve should be, according to this, 7B7 should be 1700. So if you set this to GM, you should be getting 1700, and on the 3000 micromoles range, we're getting under 1500, about 1400. So the valve is weak. There are a few things you can do to improve that, but it's very risky. Before I do that, there's the shorts test I have to run. I'm looking for this neon to illuminate in the other ranges. You see it flashes briefly, but that's fine. There's nothing wrong with that. Okay, so what you can do is do a brief overdrive on these valves. It's not really recommended, but it's a bit of a do or die situation. I'm going to increase the heater volts to 10 volts, and you see the output slowly climbing up the scale. This is basically burning any deposits off the cathode, but it is pushing the valve very hard. And bear in mind, this is quite an old valve. It doesn't always work, but you leave it for about a minute or so, let it stew a bit. You see it has come up to, well, now we're on 3000 range. It's at 1600. So are we in spec now? It's not quite. We're getting close to it, but it's sorry, this is a 7A7. I'm looking at the wrong scale. 7A7. Yeah, it's not quite in spec, but let's give it another 30 seconds or so, and let that stew and see if we can improve it any further. I've replaced the HT anode rectifier in this, which was a mercury rectifier, with a solid state rectifier now, and hence it doesn't get so hot. It used to get very hot to the touch, but it seems to stay much cooler now, and the power consumption's dropped right back. I mean, with this valve in here, I'm only drawing 25 watts, whereas before I've been drawing close on 50. So that's quite good. Okay, let's turn this down now. Let's had enough of a stew. Okay, we're looking at the output now. You see the meter dropping away now as the cathode emissions are reduced as the thing cools down. This valve's not going to recover. Oh, it's recovered slightly maybe, but not a lot. It's obviously a fairly weak valve. I'll keep it. I mean, it is usable, but obviously a valve that's done quite a lot of work and beyond its best. But yeah, that's basically a quick function of how it works. There's a number of gas tests you can do. You can test various valves. Gas test number 1, I'm not too sure exactly if it's suitable for this valve. I haven't actually got an instruction manual for this valve tester. I need to find that, and I really need to speak to someone who's had a bit more experience with it. But thanks for watching.